So this is 1.4 limit and continuity worksheet. We're doing question number 4. So use the graph of y equal to gx to determine each of the following. Limit of the gx when x go to the -2. This negative above -2 means you are getting close to -2 from left, right? From lower value. So here is your -2, x -2. So you want to get close to -2 from lower value. This negative means lower value. Now I have to look at this side of my graph. So this side of graph getting closer, x getting closer to -2, the y getting closer to what? 3, right? How about +2? What do you think, Eric?
Yeah, so for +2, if I'm looking from the right side, I think I approach to 3 as well.
Yes, if you're getting a -2 from positive side, so it's going to be close to that. So you have to look at this side of the graph. Again, you're approaching 3. So do you think the limit exists or not?
I think it does not exist.
Okay, the limit from right and left are the same. Okay, and the limit from right and left are the same. So the limit of x going to -2 exists and is equal to 3.
3, okay.
Okay, what is the value of your g of -2? Is the value of the function at when the x is -2? What would you say?
It would be 1.
Very good. You have to look at the point, field point. So at -2, the value of the function is 1. Maybe you tell me this one as well. X go to 1 from negative. So what would be the y value going to?
It would be 0.
Very good. How about from right?
It's 0 as well.
And is the limit exist?
Yeah, it's 0.
Right. And if g1 is what?
0.
0. As you see, at this point, when the limit exists and the value of the limit is equal to the value of the function, your graph is continuous. But this case, the limit exists, but the limit is not the same as the value of the function. Therefore, we have discontinuity. So here in this case is point discontinuity. Okay. Any further question from that?
I think we're good. Yeah.
Good. Okay, so let's see if we can do a little bit here. Okay, I would like to talk about that and maybe we do it for -1. So limit of the hx when you go to the -1 from left, what do you think?
1.
Yes, that's great. So we have to look at your function like that from the left. So it's 1. How about from right? That one?
Right, it would be -2.
Very good. So I have to go to this one. So this is my x -1. I'm going from right. The value of the function y value getting close to -2. What is the value of the, okay, is the limit exist or not?
It does not exist because there are.
Is the limit from right and left are not same.
Yeah, yeah.
What is the h, the value of the function at -1?
Would be 1.
Yes. Okay, so we have to look at this first circle. Now, as you see, the limit is not exist. If the limit from right and left not the same, we have again discontinuity, but it's going to be jump discontinuity.
Yep.
And this one, so it's easy. I'm going to do this question number D. You want to take the limit. Now, if you put 3 here, 1/3, 1 minus 1/3 is 0. You have 0 in the numerator. You put 3, 3 minus 3 in denominator will be 0. When you have 0/0, we have to simplify. How? In this case, we take the common denominator. So common denominator between 3 and x is 3x. So you multiply this one by x, numerator and denominator. Multiply by numerator and denominator by 3. So then it becomes x minus 3 divided by 3x. So, and we have x minus 3 over here. So here x going to 3. Now I can cancel this bracket x minus 3 from numerator and denominator. Now my problem is solved. If you sub 3, you no more get 0 in numerator and denominator. So here I have 1 over 3x. X goes to 3. So here 1 over 3 multiplied by 3. Sub 3 instead of x, and you get 1 over 9. Now, in the other cases, again, you have to get rid of the unknown bracket or unknown roots in numerator and denominator if you get 0 over 0 to get your limit. So this is an example I do from this question. I would like to do just one of that as well. Let's just do this one. Again, you put 0 in numerator, you get a square root of 3 minus the square root of 3, you get 0 in numerator. And when the x against 0 here, in denominator, we have 0. So we have to simplify. I'm just multiply this one by its conjugate. 3 minus x. Its conjugate is going to be plus, right? When again, I'm going to remind you that a minus b multiplied by a plus b is equal to a power 2 minus b power 2. Because I want to get rid of this square root, I need to multiply this one by its conjugate. So here is, because I multiplied by something, I have divided by the same thing. I don't want to change my equation. X plus 3. Now, multiplying these two is like a minus b multiplied by a plus b. You have 3 minus x. I'll make sure I have my limit. Here, limit x go to 0. So 3 minus x squared to the power of 2, the square root will cancel. It becomes 3 minus x minus square root of x plus 3 to the power of 2. Again, the square root will cancel. Divided by x, the square root of 3 minus x plus the square root of x plus 3. Now, if you simplify your numerator, maybe I just use that different color, it's going to be negative x plus x. The x and x can cancel. And become 3 minus, okay, this is 3, become 3 minus 3, which is 0. Let me just double check that. So it's 3 minus x minus x plus 3. Okay. 3 minus x, okay, minus x minus 3. Sorry, the x not canceling. The 3 and 3 cancels. And you have negative 2x in numerator. X here. The square root of 3 minus x plus square root of x plus 3. As you see now, the unwanted root is canceling, x and x. So if I substitute x by 0 now, I no more get 0, 0 in numerator and denominator. So instead of the x, I put 0, I get a square root of 3 here and a square root of 3 here, become 2 square root of 3. To simplify, it becomes negative over 1 square root of 3. Do you have any question?
No, I think it's fine. Yeah.
And these are fine, though. Just write that in a factor form and you cancel the unwanted roots, then you just sub x to be that the value.
Yeah.
Now, graph the piecewise function, determine the value of each limit. So just quickly, I want to graph it, but entirely, if you want to talk about the 2 minus x2, you know, is like, look like that. If you negate, this is minus 2, and plus 2 means you take this one 2 units up. And here is saying that graph it for x less than equal to -1. Your -1 is there. Basically, you just need to graph this part of your function. That it looks like that. And x minus 1, the x-intercept is going to be 1, right? Is here. And you have to graph it from -1. At -1 is -2. Say this is -1 and here is -2, right? So, and I need to put it not to be filled circle. I need this to be empty circle. If I'm doing that, this is going to be empty circle. Why? Because this is not equal to -1. And then this is the line. So basically this part, the black part, will be the one that you have to draw. Determine the value of each limit. The x go to -1 from positive side. See, this is -1. Positive means the higher value of the -1. So this is for x greater than -1, means this part belong to 1 to the power of plus here, right? So if you put 1 here, 1 minus 1 is, of course, is
Zero.
sorry, -1. -1 minus 1 is -2. As you see, so you have to look at that -1 here. Either it's going to be -2 from the graph, and I want you to do it from just the piecewise function. So positive, okay, from -1, from lower value of negative. So you have to look at this. So if you put -1 here, of course you get 1. As you see in the graph, you get 1 as well. You're looking at this part. Of course, the limit from right and left not the same, so it's not exist. Limit your function when it's go to 0. So you have to, the x go to 0. You have to look at that point there, which the limit from right and left are the same. So just, you have to look at this. 0 minus 1 is -1, right? So, any question?
I'm fine, yeah.
Okay, so question number 11, you want to sketch that very important question. Your function, I'm going to graph the first one. F of 5 is 0. So let's say this is 1, 2, 3, 4, 5. So at this point, then the x is 5, the y is 0. And the limit of the function from right of the 0 is -3. Is 1, 2, 3. I need to make a circle, empty circle. To say from right means whatever you do, this would be from right. Any function you draw, I could draw anything, right? As long as this side of my graph approaching to 5x approaching to 5, the y approaching to -3 would be fine. Now from left is need to approach to 1. So again, 5, 1. I can draw anything as long as this is approaching, when it x approaching to 5, y approaching to 1. That's for A. For B, I just see they are the same thing. I believe you can do the rest of that, true?
Yeah, I'll have a look. Yeah, should be fine.
I'm gonna stop this.